Problem number 19 says a quadrilateral has vertices located at -3, -5, 4, 2, 4, 1, and 2, -1. So it asks which best describes the figure. Is it a rhombus, a rectangle, a trapezoid, or a square? So let's remember real quick what these shapes look like. I've actually already drawn a sketch up here of what those points should look like when you put them on a graph. But remember, a rhombus, generally what we see is it's got all the same sides. Every side is the same length. And then there's nothing really specific about these sides right here, okay? What we're going to see is that opposite sides are parallel, but all sides are the same length. So that's a rhombus. A rectangle has opposite sides parallel, but it also has 4 right angles. That's sort of the giveaway there, and usually what we see is the opposite sides are not only parallel, but they're the same length. And then also a square has 4 right angles, and it's kind of like a mixture between a rectangle and a rhombus in that all the sides are exactly the same, and it does have the 4 right angles. So it's kind of combining the side lengths here with the angle measures here. So what we want to see also is the last shape, a trapezoid, which we draw different ways, and usually the way we talk about it is that the top side and the bottom side, the bases of the trapezoid, they are going to be parallel. So we have one set of parallel lines. Now we look at this picture that we draw that connects these 4 points that were given to us, and it, to be honest, looks like none of these, at least not the way we've seen it. So this is where we really have to go into the details of what the properties of a shape are. Now right away I can tell this is not going to be a rhombus or a square, because clearly this side right here is much longer than this, and if it was a rhombus or square, all the sides would be the same. I can also look at it and tell these are not right angles. Okay, this one's kind of opening down, this one looks like it's kind of opening out. All right, this is an acute angle, it's less than 90 degrees. This is an obtuse, bigger than 90 degrees. And this one is even a lot bigger, and this one's a lot smaller. So we've got all different angle measures. So these are not right angles, the sides are not the same. That means I can rule out a rhombus, a rectangle, and a square. So it's got to be a trapezoid, otherwise this problem is wrong. Now if it's a trapezoid, again, all that we need to prove is that we have one set of parallel lines. So there's one set of opposite sides that are parallel. I'm pretty sure that this side right here is not going to be parallel here, because this is clearly going straight up and down. This one is not. So that must mean this side right here, from this point, we'll call this A, and this point B, from A to B, that looks like it's going to be parallel with side CD. So the way we just prove this really quick is we look at the slope. We figure out how much are we going up and how much are we going over, and do rise over run. So from A to B, we're going from a y value of -5 up to +2. So that is a distance of 7. We're 5 below the x-axis here, 2 above, so that's 7 total. And if we look, we're going from an x of -3 up to +4. Okay, it's 3 on the left, 4 on the right. That's a total of 7 as well. So my slope, rise over run, from A to B, the slope between those points is going to be 7 over 7, which is 1. So the slope is just 1 from A to B. Every time we go up 1, we go over 1. And that makes sense, because eventually we're going to go up a total of 7, and we've gone over a total of 7. So now I just want to look from D to C. Okay, so we're coming up here and then coming across. And I know it's a little crowded here in the drawing, but let's look at the y values. We go from -1 to +1. How far apart are those? That's a distance of, let me grab a different color here, that's a difference of 2. We're going up 2. And then look at the x values. From 2 over to 4, that's also 2. Now we didn't go up the same amount and over the same amount compared to here, like we didn't go up 7 and over 7 again. But if we look at the slope from D to C, we're going up 2 and over 2, which is once again 1. Since these are the same slope, anytime you have two lines with the same slope, they are parallel lines. So we know that these two lines are parallel with each other, AB and DC. So this is a trapezoid since it has one set of parallel lines. So we have our shape. Even though this looked weird, this is definitely a unique looking trapezoid. Not like the traditional shape you learned about in middle school, elementary school, whenever you first learned about trapezoids. And not like any we've seen before, but by definition it is a trapezoid because it has one set of parallel lines. So that's question number 19, and if you look, that is going to be answer C. So we've got that one done. Now you can move on to the last question if you need to work on that one.